Okay, we will continue again this. So are you ready for this second topic?
Ready.
Okay, good. Okay, before this, you're talking about the water, right? Water is contain H2O, and it is polar molecules. It has a hydrogen bonding. Okay, so water also in the it makes up our 71%, and our human body is 70%. So water is very everywhere. Okay, so that's actually the uniqueness of some of the uniqueness of water. There's actually other some uniqueness of water. So there is also a term that the water has. Okay, hydrophilic and also hydrophobic. Hydro mean water. Okay, philic mean loving. Hydrophilic. Hydrophilic is loving, hydro is water, so it's a loving water. Hydrophobic is a scared of water. Phobic is phobia. Phobia of hydro, phobia of water. So you can see here, okay. So here is the molecule of water that on the surface of the hydrophobic surface here. So it will there is no interaction actually. Okay, on this surface there is water molecule. So that's why it's become what do you call this in the form of balls. Okay, or in the form of circle. And then for the hydrophilic, imagine that this is the hydrophilic surface. Okay, and this is water molecule. So there is an interaction between water molecule and also this hydrophilic surface. Okay, actually there is one technique that we actually use and to characterize the surface whether it is hydrophilic or hydrophobic. Because when we come up with the new materials, okay, new materials, the hydrophilicity and also hydrophobicity is very important, and because it can affect the many things. It can affect the interaction, it can affect the growth of the bacterium, it can affect the if you come up with the bone implant, it can affect the cells and many things. Okay, so one of the technique is by looking at the contact angle. You can see here, looking at the contact angle, we drop the water molecules and we can see the contact angle. If the contact angle is very low, and so it is a hydrophobic surface. So this is the angle lah, contact angle between water and also the surface. So this is we call it as hydrophobic surface lah. And if the contact angle is very high, okay, it's more than 90% and 90 degree, so we call it as a hydrophilic surface. So the water, the molecules here, so those contain a hydrophilic property. Okay. So sometimes when we produce a material and we coating on the surface with the hydrophilic molecules, and then it will have interaction with water. And maybe some of the surface too, we do not want to have an interaction with water. And for example, the stainless steel and besi steel, because steel ni can interact with water and it will become corrosive. So we coat with the paint. Paint tu consists of hydrocarbon. Kan hydrocarbon ni, we know that hydrocarbon it does not react with water. Hydrocarbon is contain CH kan. And hydrocarbon ni is non-polar. CH2 non-polar. So we put it on the surface, we coat on the surface of the stainless steel. So it will become hydrophobic, and then there is no interaction between water and also the stainless steel on the surface too. Okay, so this is one of the application of the hydrophobicity and also hydrophilicity lah. So you can see here, the picture here. Here is water. Okay, it does not. There is a separation between water hexane and also CCl4. CCl4 is chloroform lah. And chloroform is non-polar. Water is polar. Hexane consists of hydrocarbon. Hexane ni is a hydrocarbon, is in the family of alkane. Okay, it has a carbon, the number of carbon is 6. The number of carbon is 6. So you can see here, number of carbon is 6. So it does not react, does not interact with water, and the water does not have interaction with the chloroform. Okay. If you talk about the hydrophobic and hydrophilicity ni, we are talking about the interaction, not the reaction. Okay. In chemistry, there is a difference between interaction, attraction, and also reaction. Reaction ni, when we have compound A and plus compound B, we react together, will form compound C. So that's actually reaction. Okay, but when we call it as interaction, okay, it is interaction among water molecules. Interaction with one water, H2O, and another water, we call it as, the interaction is hydrogen bonding. Okay, there is no reaction between H2O and H2O. Okay, but if there is an NaOH or sodium hydroxide plus H2O, there will be a reaction occur. Okay, it will produce Na plus and also hydrogen. Okay, or NaOH, sodium hydroxide plus hydrochloric acid, it will react together, will become sodium chloride plus NaOH plus water. So there is a reaction. But when talking about hydrophilic and also hydrophobic, it is a interaction. Okay, interaction. And we can also say as an attraction, attract. Water cannot attract hexane. Water cannot attract chloroform. So those are the terms that you need to understand. So remember, it's different and between interaction and also reaction. When it comes to the hydrophilicity and hydrophobicity, we're talking about the interaction. So there is actually interaction between water and also the surface. Okay, there is interaction between the water molecules here with the hydrophilic surface. Interaction. Okay, so what happens if you put sugar or salt in water? So we know that, okay, if you put this sugar and want to produce a water and coffee. So when we put it inside the water, so it will dissolve. And water solvent, sugar, and then when we stir it, it will dissolve in water. So actually there is an interaction between the sugar and also water. Okay, sugar remain the same in the water. Okay, remain the same in the water, but maybe some of the physical properties is different lah. From solid, it comes with the liquid. So that's physical properties. The molecules is still the same, but maybe some of the molecules, the macro environment of the molecules a little bit different between the solid and also the solution. Okay. Okay, we'll talk about hydrophilic. So this is actually what I want to tell you about, that some of the element, okay, they can be dissolved in water. Okay, they have interaction with water, unlike this hexane and also chloroform. Okay. So first we're talking about hydrophilic. Hydrophilic ni, the categories of the molecules is ionic and polar molecules. And hydrophilic is come from the word Greek hydro, water, and also philos. Philos is living lah, living water. Water dissolved chemicals have an affinity for it. So we call it as hydrophilic or water living. So these are two categories. One is ionic compound, and for example, like sodium chloride. So this is what I told you about this charge. It's a full charge, and A plus, and also chloride ion, and positive and also negative. Unlike water delta positive and also delta negative. And delta positive come from the H. Delta negative come from the oxygen. And also B, polar organic compounds. And partial charge, ni same like water lah. Alcohol tu also contain delta negative and also delta positive. Ketone, ketone ni contain C double bond O or carbonyl group. It also have a delta positive and also delta negative. So ionic compound, sodium chloride, is a hydrophilic. Polar organic compounds such as alcohol and ketone, and because water also is a polar. This organic compounds is so polar. So there is a polar interaction. Okay. Unlike hexane, hexane too is a non-polar. Okay. It is a non-polar because of the CH. So non-polar does not react with the polar molecules. Okay. So this compound are soluble in water due to three kinds of a non-covalent interaction. Okay. Ion dipole. For example, like sodium chloride, dipole, alcohol or sugar, and hydrogen bonding. Special case of dipole interaction. Okay, we'll look at this. So ion dipole interaction, ions are hydrated by water molecules. Water, we know that it is a polar molecules. This polar molecule, delta positive, delta negative, can attract charged ions. Okay, and the shell of water molecules that cluster around both negative and positive ions is a solvation or hydration sphere. If you see here, this is the chloride ion. Okay, chloride ion, it will give a negatively charged, and the water, it has a delta positive. So this delta positive can attract with the negative, delta positive and also negative, and it will become a solvation or hydration sphere. Okay, slightly positive hydrogen are attracted to chlorine and ion. So this is what I told you before. We use the term attracted or attraction. And okay, sodium. Sodium, it has a positive. So positive ni will attract negative. 2 delta negative. From where? From the oxygen. And this is the water molecule. Okay, this is the water molecule. Slightly negative oxygen are attracted to sodium cations. So we call it as attraction or interaction. So here we don't call it as reaction. Okay, there is no reaction here. A plus will not react. There is just only interaction. So this is the interaction of ion dipole, and because of the charge negative and also charge positive. Okay, dipole interaction and hydrogen bonding. So here dipole interaction, you see this is the alcohol. Okay, alcohol is contain OH, and it combined with the hydrocarbon. Okay, so this is dipole. There is a dipole because it's uneven distribution of the electron, and similar goes to the water. Water also, it has a dipole because of the uneven distribution of the electron. Okay, so they attract with each other. And another one, the same goes to the alcohol here. Okay, because alcohol contain O and H. Okay, H from water molecule will attract with the oxygen here, because oxygen is a electronegative atom. Okay, oxygen in the water also will attract with the hydrogen here. Okay, however, there is no interaction between this oxygen and hydrogen that attach to the carbon. Why? Because CH here, and the electronegativity is very low, the CH. But the OH, the electronegativity is very different. Okay, the polarity is very high, OH here. So the H will only attract with the oxygen, and the oxygen attract with the H that attach to oxygen. Okay. So in terms of the strength of hydrogen bonding, fluorine F is the most electronegative element. So HF bonds are most polar and exhibit strongest hydrogen bonding. Let me see, HF is more than HO is more than HN. One of the acids, acid N, hydrofluoric acid. Okay, you know about hydrochloric acid. You know about the hydrobromide. Okay, there is also one of the acid which is HF, hydrofluoric acid. Hydrofluoric acid is very reactive. It can cause cancer. And when we want to handle this HF, you need a full of PPE, personal protective equipment. You cannot just handle this HF by using your bare hand. You cannot. You need to have a full PPE, and it will react with our human body, with our skin, HF ini. Okay, so because of what? Because it is a very strong hydrogen bond, it's very reactive. Okay. This is hydrophobic. So before this, talking about hydrophilic, right? So hydrophilic, we have a three interaction. Okay, ion dipole, dipole, and also hydrogen bonding. Now we look at the hydrophobic. Hydrophobic ni is a non-polar molecules, like I told you. Okay, hydrophilic is a polar molecules or polar molecules or ionic molecules. Okay. Now for the hydrophobic is non-polar molecule. Okay. So from the word for both is from the Greek words is a fearing. So if fear the water, will not love the water, and it will what do you call this? It will not attract with the water. So hydro is water lah. So hydrocarbon, CH, for example like hexane, they have no polar bonds, or the bonds dipole cancel due to molecular geometry. Okay, like I told you about the methane, for example. Methane too, it has a CH. CH is a non-polar. It's a non-polar bonds. And these molecules do not form good attraction with the water molecule. And because of this, and this hydrocarbon is not soluble in water, and it is considered as hydrophobic. And for example, like hexane. Here is the hexane. Hexane, although it is in the form of solution, it will not react. No, it will not have interaction with water. It will not dissolve in water. It will not what do you call this? Position together inside the water. Okay, it will have a layer, and this is one layer. This is water is another layer. Okay, so example of the non-polar molecules are hexane, because it's contain so many hydrocarbon here, and also cell membrane. So if you see here, the cell membrane here, okay, it consists of hydrophobic tail and also hydrophilic tail, hydrophilic head, and also hydrophobic tail. And there is so many hydrocarbon here, and these are the water. So the water is just only form what they call this hydrogen bonded cage-like structure around the hydrophobic molecules, forcing them out of solution. So it will not interact between the water molecules and also the hydrophobic molecules. Okay. Okay, I want to ask you. We know that apples that you got it in the supermarket, and you go to Ion, you find that all of the apples, they are wet. They have this wet on the surface of the apple. This is the structure of wets, where it's contain so many hydrocarbon here. Hydrocarbon. Okay, so because it has so many hydrocarbon, and wets is actually considered as hydrophobic or non-polar molecules. Okay, hydrophobic. So natural wets like shellac and carnauba wets are used not used just for apple, but also for a variety of fruits and veggie. Same wets found on dental floss, vitamins, and chocolate candies. Okay, but the very significant is wets on the apple. So why do you think? Why do you think? What is the purpose of this? Can you put it in the chat? I want to see whether you know or you come up with your opinion based on what you have learned about the hydrophobic, hydrophilic or hydrophobic, kan? Especially on the hydrophobic lah. Please put in the chat, okay, your opinion. Or maybe you know about this before this. Okay. Okay, please take time to put it in the chat. Okay, some say that keep apple look fresh from ladang. Yes, of course. Thank you, Ahmad. It looks fresh and from ladang. Maybe the ladang is not from here. Okay, it's from the New Zealand, come from the Australia. So the appearance will look fresh. Some say that to prevent interaction between the fruits and water, and you ask me, okay, is it to prevent interaction between the fruits and water? Okay, we'll look at this. Shazwana asked me. Prevent oxidation of apple. Yes, correct. And so what happened when apple oxidize? So like Ahmed Hazman said, that will not look fresh lah, kan, as compared to the the wax. To avoid reaction to occur, prevent oxidation. Yes, yep. Retain moisture and firmness of apple. Yes. Avoid loss of water and prevent the apple from rotten. Yes, yes, of course. Yep. Prevent water loss from the inside of water, hence keep it fresh. Yes. That's also one thing lah. Okay. To retain moisture and prevent oxidation, makes more appealing and attractive. Yes. Yep. I agree with all of the opinion that you put it in the chat. Okay. So actually the most important is that and it will create the surface of hydrophobic. Like I told you, if the surface of the apple too is hydrophilic, so the water will interact with the surface of the apple and punya kulit itu, and then it will interact with the inside the apple. So there will be oxidized. Once it's oxidized, it's not good lah. Okay. And dia panggil what they call this, dia it looks hitam-hitam lah, blackish macam tu. However, if they put wax and on the surface of the apple tu, and the surface will become hydrophobic. So once it's become hydrophobic, the water from outside, from environment ke, from the washing ke, okay, especially from environment lah, okay, so will not have interaction with the surface. Okay, so it will remain this the surface tu will prevent water interact with uh, the skin of the apple, and then after that interact with the inside the apple. Okay, so that's why we put it first. Okay, thanks for the comment that you gave. Okay, the comment that you gave just now. Okay, okay, another molecules, another what they call this, the properties related to the water, which is amphipathic molecules. Okay, hydrophilic is a non-polar. Hydrophilic is a polar and also ionic molecules. It have an interaction with the water, so that is hydrophilic. Hydrophobic is a non-polar molecules, does not have a interaction with a water molecule. However, there is a molecules that have both, and has both. It has a hydrophilic and also hydrophobic in one molecule. So this is actually very unique, and there is so many applications of this amphipathic molecules. So inside the amphipathic molecule, it has a both polar and non-polar groups. And, for example, ionized fatty acid. We learned this in lipid. And fatty acid is amphipathic. So the carboxylate group is water soluble. So inside the fatty acid, there is a carboxylate group, COO minus or C double bond O, OH is water soluble, and it has a long carbon chain which is not soluble. And for example, here if you see the structure here is the organic molecule, phosphate. So these are the polar head. This is not the carboxylate anion. It's an organic molecule. It's a phosphate. So these are the polar head. It consists of CO and also phosphate PO, and then it has a covalent bonding. It's not the interaction. This is one molecule. So this one molecule is the what do you call this? The interaction is the covalent bonding. Covalent bonding, and it has two region. One is polar head, which is hydrophilic. Another one is non-polar tail. We call it as tail, hydrophobic. So for this one, at the non-polar tail ni is composed of diglycerol or glycerol plus 2 fatty acid. Fatty acids in contain so many hydrocarbon lah. While for the polar head ni, hydrophilic, it contain organic molecule which is choline, and you will find this in the lipid. And then it will give it can attract with water, okay, because of the phosphate and also this choline. And amphipathic molecules tend to form micelle. So what is micelle? Micelle is like a foam, buih. Okay, those are the micelle. Micelle is a colloidal aggregates with the charged head facing outward to the water, and the non-polar tail part inside this micelle. Okay. Amphipathic molecules have hydrophobic chain and ionic or polar. For example, like detergent, surfactant tu kan, detergent that you use to wash your clothes. So it will form a foam way. So those are the micelle. And the higher the concentration of the detergent in the water, so we'll see there is a lot of foam. There's a lot of way lah. Okay, so it's actually form a lot of micelles there. So you can see here. So this is the micelle, and the hydrophobic will attract together with the same molecules, same tails, non-polar tails, and hydrophilic head here, okay, will attract with the water. Okay, so this is one of the uniqueness of the amphipathic molecules lah. What is surfactant? Surfactant is a short name for the surface active agents, and most of the surfactants is contain hydrophilic and also hydrophobic. Why we call it as surface active agent? Because these surfactant molecules can active what do you call it, interact with water and also the organic compound, and water and also the oil. It can actually, this surfactant, okay, when you put this water and oil together, it will not mix. Okay, it will have a 2 layers. But if you put it surfactant, this surfactant will mix at the layer of the water and also oil, and then it will mix together water and also oil. So it will become the surface between the water and also oil to active. So that's why we call it surfactant, surface active agent. Agent that can active the surface between the surface of water and also surface of the oil. Okay, in chemistry, we call it we learn about the surface chemistry actually. There is a solid to solid surface. There is a solid to liquid surface. There is a like for example in our hand. Okay, this hand is a solid, and the surface is the gas. We put it in the water, and inside the water, there is an interaction between the solid and also liquid. Okay, solid is our skin, water is the liquid. So solid to liquid surface. And we put it together like this. Okay, we put it together like this. There is a solid and also solid interaction. Okay, so there is a solid to solid interaction, solid to liquid interaction, solid to gas interaction. There is also water to water interaction or solution to solution interaction. Sorry, yeah. So water, a solution to solution interaction. So water and oil, there is actually interaction or surface. Surface of water interact with the surface of oil. So there is something happen there. Surface too. Okay. So that's actually in chemistry lah. All of them they have a surface. Okay, one more thing is about colloid. There is one situation where the very fine particles is not dissolved in water, but it looks like dissolved in water, but it's not dissolved. There is a fine particles is dispersed inside the solution. For example, like if you see here, stable colloidal solution. So we call it as a colloid or colloidal solution, where the fine particles here, they are dispersed in the solution. Okay, but if we see using our own eyes, we can see there is no particles inside there. Okay? But we can determine this whether it is it has a colloidal or not using UV visible spectrophotometer spectroscopy. If the colloidal is not stable, so we call it as because some of the aggregation occurs or agglomeration occurs, and there is interaction among the fine particles here, and is combined together. Okay, or it will sediment and at the bottom of the this solution. So this is unstable colloidal solution. Okay, so example of the colloid is the some of molecules in cells. For example, like cotton. Cotton ni is a giant molecules of cellulose. Cellulose is carbohydrate lah. And water adheres to the cellulose fiber. So that's why towel will not dissolve in washing machine. Okay, because it just only have an interaction. It has an interaction with water, but it does not dissolve the water. Okay. So before we go to the section break, so here is the again talking about the hydrophilic, okay, and also hydrophobic. Hydrophilic is ionic and polar molecules. They will have three interaction: ion dipole, dipole, and also hydrogen bonding. Okay, this is ion dipole, dipole interaction, and also hydrogen bonding. Hydrophobic, okay, is a non-polar molecules. Why is hydrophobic? Okay, what is non-polar? Okay, amphipathic molecules that contain both polar and non-polar groups, and they contain hydrophilic and also hydrophobic in one molecules. Talking about colloid. Okay, colloidal solution. Okay, before we go to the section break, do you have any question? You can put it in chat. Tay Pen asked me, okay. So does my cells help in removing impurities on clothes? If so, how does it occur? Oh, okay, that's a good. Does the micelle help in removing impurities in clothes? If so, how does it occurs? Okay. Okay, to answer this question, you look at the amphipathic molecules here. Okay. Amphipathic molecules ni, and you can also see this in the detergent or in the surfactant. In the surfactant, there is a polar head and also non-polar tail, or at this region is a hydrophilic, and this region is a hydrophobic. Okay, so most of the impurities or most of the contaminants is come from the organic molecules or come from oil, and the dirt tu come from oil, not the minyak lah. Okay, it come from oil. Our, for example, like what do you call this, the protein ke kan, it is composed of hydrocarbon. Okay, so this hydrophobic region here can attract oil ke wax ke hydrocarbon, biomolecules ke, so it can attract this at this region. While for at this polar head ni, it will attract the water. Okay, it will attract water. So on the surface of the clothes, baju tu, fabric, and there will be some of the stain. Stain tu maybe come from the oil, yeah, or the what do you call this, the yalah makanan ke kan, sambal belacan ke kan. So those all will not have a reaction with the fabric unless it is a dye. Kan, coloran tu have interaction with fabric lah. So that's one is we cannot remove it because it's have interaction with the strong interaction with the what do you call this, the fabric. Fabric ni cotton. Fabric ni also is organic molecules. So it have interaction with the dye. But oil and does not have interaction with the fabric. Okay. So oil ni will be attracted with the tails of the surfactant tu, and then during washing tu, we remove the water. Right? We have a medium. The medium is water, and water we put the surfactant, and we wash. First we first kalau if you see the concept of washing machine tu, first we put it detergent, and then it will become a micelle buih lah. Okay, will become micelle. So the micelle tu will attract the oil in the fabric, and it does not react with the fabric. Okay, water also will not react with the fabric. Okay, and then you wash it. Okay, you remove the water. Okay, and the clothes too will remain in the washing machine. And then you put water again, and you bilas, and then you rinse many times to make sure that there is no what do you call this, surfactant in the washing machine, and also oil also in the on the fabric. That's why I want to tell you, okay? That's why I want to tell you, just use a little amount of surfactant only or detergent. As long as it will form a foam or buih, that's enough. Okay, and that's why you also need to know the type of the detergent. Okay, if you use dynamo or if you use breeze liquid, breeze tu kan, it says that concentrated detergent. Just use only small amount only. Okay, if you use the powder one, so that's not detergent. Okay, so that's why they have the level of the how many amount that you need to use for one washing machine. Okay, because if you put it too many surfactant and you are not rinsed properly, the surfactant tu will remain in your clothes, and this surfactant can attract more oil as compared to the clothes. To the chemistry of surfactant tu. Okay, the good thing about you learn about the chemistry ni, you will know how to use these chemicals. Okay, so that's why you cannot use so many detergent in a small washing machine. Okay, there's a important level lah. So hope we can understand that lah. Okay, you understand right? Do you have any another example for colloid? Okay, one example is what do you call this? I'm doing now. The research that I've doing now is a silver nanoparticle. Silver nanoparticle. Silver lah. Macam you're using apa nama tu, your ring ke, your necklace ke, itu silver. Okay. Silver can be in the form of nanoparticle. The particle is very small. It's a nano size, 20 to 50 nanometer. And so it's very small. It's in the form of particle. So the particle still remain in the solution. There is a medium that we use, and surfactant also is one of the medium that we use to maintain the particles maintain the particles in the form of nano size. It will not agglomerate, become stable lah. So these are the colloidal. Okay, we cannot see in our own eyes. Okay, we cannot see in our own eyes. We can just see that it is a solution. Sometimes it's a clear solution, but it's actually the colloidal. So those are example of colloidal. Okay, we call it as a colloid. And one of the characteristic that we use, one of the characterization tool that we can use to determine the colloid is by using ultraviolet visible spectrophotometer. I think you will learn this in the next semester subject article chemistry. Okay. Thanks for asking. Okay. Hopefully, do you understand? Once you understand about the water, you will understand more about the chemistry of other compounds lah, or other chemicals. Okay, so we go to the active learning. So same like before, individually, sharing your illustration. Take out a piece of paper, or you can come up with using PowerPoint ke, and if you're using tab, it's up to you. Okay. If you're using a piece of paper, come up with a A4 paper tu, nanti take a picture and share in FB group. So same like before, please wait for the video that I will upload in the Facebook group. Okay, and then you can put it in the comment there. Okay, please do this not after class. Maybe I will give you more time lah, until this Thursday ke kan. For the announcement, I will put it in the what do you call this, in the Facebook group. Not today. Okay, if not today, just you can just log into the Facebook group and see the announcements from me. Yep. So what is the illustration that you need to come out? Okay, the interaction between first is the glucose and water. Glucose is one of the carbohydrate. You can Google the structure of the glucose. And acetic acid. Acetic acid ni is one of the weak acid. Weak acid, and there is an interaction with water, and also surfactant and water. So how about interaction? Okay.